Hello students and good afternoon. How are you today? Are you all good? Well, today I think today we have two sessions and so it's a good opportunity to finish this part. I mean section 1. And so I think today I will upload the complete file of chapter 1 on the Darsa website and so it will be available to you for download. And um, but before I start the start uh, lesson, just let me to replace the file with the newest one. And chapter 1, the newest PDF file is here. How many courses do you have in this semester? How many courses do you have in this semester? Are you there? How many courses, how many lessons do you have this semester? 3? What are the other courses? What are? What are the other 2 courses? Okay, what are the other 2 courses? Name it. Okay, I know. You have 3 courses this semester. One is distributed systems. What about 2 others? مخابرات. Well, so you are hardware, I think, yeah? You are studying hardware computer engineering, I think. So they call it data mining or knowledge discovery from data is called something. I can assure you, okay, I can assure you, I mean, you can be sure that this course, distributed system, is the easiest course of you. So you can gain a very good mark at the end of this semester if you want. There is a condition here. If you want, you can get a very good mark, a top mark from this course at the end of this semester. It's not a hard and difficult course. Good. So in the last session, we talked about different forms of transparency in distributed systems. So we were here, weren't we? We talked about the last slide we talked about in the last session is about transparency forms in distributed systems. Different forms of transparency. Did we talk about degree of transparency last session? Did we talk about degree of transparency in the last session? You don't remember? No. So, we continue from here. Degree of transparency. What do you think about degree of transparency? We said that transparency is an important goal in distributed systems, if you remember. I hope you remember. However, the question is that how much transparency do we need, really? In other words, is it a good idea to have a full transparency always? Is it a good idea to have a full transparency always in every situation for any application? Is it a good idea? If yes, why? And if no, why? I don't want you to search about it. I want to guess. You know the meaning of transparency. We talked about different forms of transparency here. Access transparency, location transparency, migration, relocation, replication, concurrency, and failure transparency. We talked about these forms in depth, in fact. And so we talked a lot about different forms of transparency. We said that we need to provide different forms of transparency for our distributed systems. Then users can see the system as a single coherent system. It's because of transparency. Now, I ask you, is it a good idea to have a full transparency always? I mean, How much transparency do we need? How much transparency do we need? What do you think? Tell me about your guess. Tell me, what do you think? Look at this picture. One form of transparency is about location transparency. Can you remember what does it mean, location transparency? Location transparency. No? Why no? We talked about it a lot. No, it's not. I'm waiting for other students. What is location transparency? We talked about it. Users may be located in different continents. It's not complete. No. If you look at the table and you read the description, you can, yes, hide resource. Just look at the description. Location transparency, hide where a resource is located. It is location transparency. So if we can hide the location of our resources, so in our system we have location transparency. It's about failure, Mr. Ahmad, completely hiding failures. It's about failure transparency, not location transparency. For example, if you remember, we talked about online banking, I think. So, when you are using online banking, for example, you want to transfer money between your account, okay? Transfer money between your accounts. So you use your online banking service. And in this situation, I asked you, do you know where the servers are located? Bank servers. The servers that stores your data, your information, account information. Do you know where are the servers? Do you know the location of the servers? No, you don't know. So the location is hidden. So we have location transparency. So we have location transparency in this example. Is it a good idea that we have always full transparency, for example, full location transparency? You don't know anything about the location in distributed systems. Is it a good idea? Is it a good idea that we have location transparency in distributed systems fully? Please answer my question. What are you saying? Mr. Amir, yeah. For users, it is good and important, but for owners, no. No, it's not correct. Tell me an example that location transparency is not a good idea. Think about an example that location transparency is not a good idea. Okay, Mr. Muhammad, we talked about different forms of transparency in distributed systems, okay? And we said that we need to provide these forms of transparency so we can have distributed transparency. I mean, in such a way, users can see the system as a single coherent system. If you remember the definition of distributed system, in the second part we said that users must see this distributed system as a single system. How? With these forms of transparency. For example, one form of transparency is location transparency. It's about hiding the location of resources in distributed system. And as an example, assume that you are using online banking or you are using your WhatsApp. WhatsApp application is a social network installed on your mobile phones, okay? You are using your WhatsApp application, so definitely we have some servers that stores users' information. They are Microsoft servers. The question is that, do you know where the servers are located? Do you know the location of the servers? No, you don't know. So it is because we have location transparency here. Now my question is that, do you think fully transparency is always good? Or can you give me an example that location transparency is not a good idea? Thank you, Mr. Amir, but let me explain more, give you more explanation. Suppose we have a printer, okay, and this printer is shared between some users. So, is it a good idea that users do not know about the location of the printer? Is it a good idea? No, it's not. Users must know the location of the printer. Why? Because if we don't know where the printer is located, probably our prints may be printed in other countries, for example. We must know the location of the printer in this example. So, in this example, location transparency is not a good idea. Got it? Thank you. It's about degree of transparency. Degree of transparency. How much transparency do we need in our distributed systems? I want to give you another example. Assume that you want to have a newspaper in your mailbox, email, I mean, your mailbox every morning exactly at 7 a.m. At 7 a.m. You want to see, for example, New York Times newspaper PDF file in your mailbox. So, the application that provides you such service must know your location it is essential that it knows your location, because you want to see the newspaper exactly at 7 o'clock. So location transparency in this example is not a good idea. Good. The other important thing is about performance. As you can see, full transparency will cost performance. What does it mean? Tell me, what do you think about it? Full transparency will cost performance. It means we have a trade-off between transparency and performance. In some situations, if we increase the degree of transparency, we may lose the performance. Got it? Yes. As an example, for example, web caching is something about storing some files on your computer, on your laptop, on your mobile phone, on your device. Do you know what is web caching? Do you know about caching? Cache. Part of memory. Yes, okay. If you visit a website for the first time, you need to download all the files, all the images, all the text, all the, I don't know, video clips, sounds, etc. Templates, graphics. So it takes a few seconds, for example 10 seconds. But tomorrow, when you want to visit this website again tomorrow, it will be loaded quickly. Why? Because some important files, images, graphics are stored in your computer. It is cache. It is caching. Okay. So web caching is a good idea for increasing performance. But there is an important issue about caching. What's the issue? When you are using caching, what's the main issue? Do you agree that caching is using copy of data? Okay. So when you are using caching, it means that you are storing a copy of some data, a copy of images, templates, text of the website, master website. So when we have 2 or more copies of data, remember replication. When we have some copies of data, the issue is about consistency. It means the copies must be up to date with each other. So in web caching, the issue is about consistency. The files that are stored in your computer must be updated with the master website because it's a copy of it. The master may change. The master files may be changed. So your cached files needs to be updated. So if we want to update these two copies, how often your cache must be being updated? Every 1 hour, every 10 hours, every 2 days? How often? It is the degree of transparency. If you want to make your system fully transparent, it means that your cached files must be updated every few seconds, every 2 seconds, for example, okay? And as a result, every 2 seconds, you have to refresh your cached files, and it decreases the performance because you need to communicate with master website. You need to use bandwidths. You need to transfer data between your computer and master website. It decreases the performance. But if you decide to decrease the degree of transparency, and so you, for example, every 2 days you want to update your cached files, then the performance is decreased because there is no need to immediately, in every second, your cached file being updated. Yes, or it is deleted after leaving the program. Yes, normally every 1 or every 2 days, cached files are being updated with the master. So, in this case, we don't have fully transparency. Why we don't have fully transparency? Because some inconsistency may occur. If the master website changed the template, changed some news, changed some text, changed some pictures, you do not be aware of it until your cache file is being updated. How do we control transparency? We will talk about it. Okay, so I assume that you completely understand what is the degree of transparency. Was it clear? Yes, Mr. Amir. Why a little? What's the problem? Ask me. Okay, the other example. See the last sentence in this slide. It's about immediately flushing write operations to disk for fault tolerance. If you remember in this slide, if you remember, failure transparency is another form of transparency. Okay, we are talking about failure transparency in this example. Failure transparency is when we try to hide the failure and recovery of a resource. So, if a resource fails and it recovers, you don't be aware of it. In this case, we have failure transparency. Now, for fault tolerance and failure transparency, suppose we try to immediately do right operation when you are, for example, when you are typing an article, a paper in Word, Office Word, okay, you are typing something. If your document immediately is being saved in every 1 second, So if power cut occurs, you do know what is power cut? Power cut. قطعی برق. Power cut. Okay? Your computer will shut down. Do you know what is power cut? Your computer suddenly shut down. Okay? Okay. So, for fault tolerance, you don't want to lose your information. You are typing a document, it's very long, for example, 10 pages or 20 pages document. It's a good article, and so every 1 second, you save your document, or it is automatically being saved every 1 second. So in power cut, you may lose only one word at most. Okay? Do you agree? So it's a very good for fault tolerance. We have a full transparency in terms of failure transparency. Okay? You will not miss anything, because in every 1 second, you save your document. Control S, Control S, Control S, again Control S, every 1 second. But it decreases performance. Why? Because you are using some services to write on disk every 1 second. Your hard disk is busy always. So the performance is decreased in this case. So you decide to decrease the degree of transparency, failure transparency. So you decide to save your document every 1 minute, for example, every 1 minute, not every 1 second, every 1 minute. So in power cut, you may lose some sentences, but in this case, your performance is not decreased. It is a trade-off. Trade-off, موازنه between performance and transparency. Got it? Thank you. So, Mr. Amir, can you please explain it to your friends after the class? I think some students may don't understand exactly. Okay, very good. So there is a trade-off between trade-off. Do you know what is trade-off? Trade-off. Trade-off. I think it is موازنه. Between performance and transparency. It means if you increase transparency, the performance is decreased. Like a meson. I try to use Arabic words here, like mizan. Mizan. Tawazun. Exactly. Yes. Tawazun. Tawazun. If you decrease transparency, the performance is increased. It depends on the application, it depends on the system, it depends on the administrator, it depends on the users to calculate this trade-off. And there is no an exact answer how much transparency do we need. It depends on many things. In some cases, we need a full transparency. In some cases, we need a low degree of transparency because performance is much important for us. So it depends. Yes, balancing between these two. Very good. Thank you. And about openness. Openness is another goal of distributed systems, if you remember. Let me come back to this slide here. Goals of distributed systems. We talked about availability, we talked about transparency and different forms of transparency and also degree of transparency. And now the third goal of distributed systems is about openness. So what is it? Openness. In short, open distributed system is a system that we easily can extend it by adding more resources, more services. It is openness. Upgrading, it's not exactly about upgrading. It's about adding new resources and new services. Maybe we can say it is upgrading. But let me give you another definition. The openness of a computer system is the characteristic that determines whether the system can be extended and re-implemented in many different various ways, I think. The openness of distributed systems is determined by the degree to which new resource sharing services can be added and made available for use by client programs, for example, or users. It is the meaning of openness. If we want to make our distributed system open, we have to provide services in standard protocols. Standard protocols. Standard rules. In these protocols, syntax and the definition of services are clear. So it will be easy for others to add new services because all protocols are clear. All protocols are clear. So adding new services would be easy for programmers to this system. Yes, syntax and semantics. Syntax and semantics. For example, we can use some interfaces. In these interfaces, the definition of functions are clear. How many parameters have this function? What are the type of parameters? For example, 2 integers and 1 string. These are parameters of this function. And what is the value of or the type of return of this function? It is interface. So when we use standard interfaces in our protocols, it would be easy to use them to add new services to the system. As an example, suppose that we are using Adobe Connect for our e-learning here. Okay, it's a type of video conference. I can share this PDF file, you can see it, and you can hear me, and you can chat with me, and also I can chat with you. So we have some services in this distributed system. It's a type of DMMS, if you remember, distributed multimedia system. Okay, so it is open. Why? Because if Adobe Corporation wants to add a new service for file sharing between students, it is not difficult. It can be implemented easily because file transferring protocols, FTP, is known and it is clear. We have some protocols for file transferring. It is called FTP, File Transfer Protocol. By using such protocols, programmers can add new service to this program. So, for example, you can share and send files between you and your friends, for example, here. So, it is an open system. Got it? Open systems are usually flexible and portable. Flexible and portable. What does it mean, portable? Portable, it means, for example, you are using an application in your system. If it is easy to run and execute your application in another operating system, so it is open computer system. It is because it supports portability. And flexibility. If a system is flexible, then adding new resources would be easy to this system. Openness. I think we talked about adding resources. And what are resources? Hardware, platform, languages, and anything else. Yes, compatible with other operating systems. Okay. Policies and mechanisms. To implement openness, we require some policies about what? About the level of consistency that we require for cache data. What level of consistency do we require for client cache data? Which operations do we allow downloaded code to perform? Which quality of service requirements do we adjust in the face of varying bandwidth? And what level of secrecy do we require for communication? And what are mechanisms? Mechanisms are some solutions to implement such policies. For example, for security, we can use different encryption algorithms to provide the level of security that we need. What are encryption algorithms? Some algorithms that encrypt data, change data to something else for increasing security. For example, your password is encrypted and then it is stored in the database. And also about client cache data. What level of consistency do we require for client cache data? We can adjust the setting for cache data. For example, the size of the disk that you want to be used for caching files, caching data. You can adjust the size of this area for caching, okay? But you cannot adjust the duration of this cache data to be valid. For example, 2 days, 3 days, 1 week, it is not your responsible. You cannot change this setting. It is done by the master. And scalability. Scalability is the last goal of distributed systems. We talked about it a lot. What's the definition for scalability? What is the definition for scalability? Yes. I said that if we increase the input, I mean the resources or users, and when the performance is not decreased, so our system is scalable. So we can talk about scalability in three components. The first one is about number of users and process. It is size scalability. For example, in our video conference application Adobe Connect, if some users are added to this class, if the performance is not decreased, so it is size scalable, or it is scalable in terms of size by adding new users or processes. Size scalability. Okay, clear? The other component of scalability is about geographical scalability, maximum distance between nodes. For example, if we increase the distance between nodes in our distributed system and performance is not decreased, so our system is scalable in terms of geography. It is called geographical scalability, increasing the distance. For example, I am in Mashhad, you are in Baghdad, Karbala, Najaf, or some other cities. So if some users are connected through this application from, for example, England or Brazil, and if the performance is not decreased, our system is scalable in terms of geographical. Got it? Well, and the last component is about number of administrative domains. It means if some administrative domains or administrators, the number of administrators is increased, and if the performance is not decreased, so our system is scalable in terms of administrative scalability. It's not true that you think in our system or in distributed systems there is only one administrator. Usually we have different administrative domains in our distributed system. So these are different components of scalability. So scalability is not only in terms of size. It's not only in terms of size. It's about administration. Administration means مدیریت. Yes? مدیریت, or do you have a better word in Arabic for administrator? Someone who makes some policies. Yes, اداره. It's better, اداره. Yeah. In distributed systems, usually we have different and more than one administrative domains. We don't have only one admin. So if the number of admins are increased and the performance is not decreased, our system is scalable in terms of administration. Good. And what are the main problems of scalability? Suppose you want to make your system scalable in terms of size, geography, and administration. Okay, what are the main problems? The first problem is about centralized services. For example, if you have one single server, that this server only provides services for users, increasing the number of users results in more access to the server. We have only one server. All the users want to access this server, and the problem is bottleneck. So centralized services is a problem for scalability. Clear? No? Okay. Centralized means متمرکز. Okay? Centralized services. serviceهای متمرکز. If we have centralized services in our system, then by adding the number of users, the performance is decreased. Why? Because all the users want to access to this server. we have only one server and we have many users. All the users want to use this server. So the problem is bottleneck. Bottleneck decreases the performance. So it is a problem for scalability. You know, the scalability says that with increasing in the number of users, the performance is not decreased. But if we use centralized services, it would be a problem for scalability. Was it clear? What do you say, Mr. Ahmed? We don't talk about failure. Yes, the performance is decreased, Mr. Amir. For example, suppose that Google uses only one server to provide services for all users. Okay, if the number of users increase because all the users want to get service from this single server, it would be bottleneck, traffic of data transmission. Okay, so the performance is decreased, low speed data transmission, low speed service. It is decrease of performance. So it is not scalable. It's a problem for scalability, because we say that a scalable system is a system that with increasing the number of users, the performance is not decreased. Good. And the other one is centralized data. Centralized data, like centralized services, is another problem for scalability. Suppose that all the data of users are stored in one server, in one location, in a single location. So all the users want to access this database, and it would be a traffic, it would be bottleneck, and the performance is decreased again. So centralized data is another problem for scalability. Okay? And the last one is about centralized algorithms. In some cases, we have some algorithms for doing something in our system. If our algorithms are centralized, again, communication with other nodes are increased and the performance is decreased. For example, suppose we have some routing algorithms in our distributed system. Do you know what is routing? Routing. Routing in network. What is routing in a network? Finding the best path. Finding the best path between two nodes to transfer data, information. It is routing, okay? It's about masir. Now assume we have different nodes in our system, in our network, and node 1 wants to send data to node 5, for example. Node 1 and node 5 are not directly connected to each other. They are not directly connected. So we must find the best path. The best path means the quickest path and not expensive path and more reliable path. We want to find this path to send data between node 1 and node 5. We use some algorithms to find this path. If our routing algorithms are stored in one single server, centralized algorithms, then it will decrease the performance. Why? Because our server must be aware about the state of all nodes in the network. The state of all nodes. Which node is off? Which node is on? And the state of the path between two nodes. Is it busy? Is it free? And is it quick or low? So all the information must be together to be gathered to this server for our algorithms, and it is a huge data transmission, and the performance again is decreased. Got it? Almost yes. Thanks God. Good. Okay. If it's difficult to understand my English accent, you can use number 13 class recorded sessions. In this class, Mr. Aqil translates my speak to Arabic. So I think it would be easier for you to understand the lesson. Okay. So we talked about some problems of scalability. And what are the solutions? What are the solutions? For centralized services, the solution is to use decentralized services. Using decentralized services can be a good solution. It can help us to increase the performance. So we must use decentralized services. How about centralized data? It is a good idea to replicate data, decentralized data. It means it is better idea to distribute your data between different servers, between different locations. It is not a good idea to centralize all the data in one database. You can use decentralized data in this case. And it's again for centralized algorithms. Using decentralized algorithms can be a good solution to solve this problem. Decentralized services and decentralized data are clear. For example, in online banking, it's a good idea to use different servers to store data, not one single server. So we won't have bottleneck problem. If we have some servers, for example, 3 or 4 servers instead of one single server. But about decentralized algorithms, decentralized algorithms have some characteristics. For example, no machine has complete information about the system state. Machines make decisions based only on local information. Failure of one machine does not ruin the algorithm. Algorithm can work. And there is no implicit assumption that a global clock exists. It's important. There is no implicit assumption that a global clock exists in our distributed system. What does it mean, global clock? Global clock is like an exact clock that all the machines that all the machines are synced with that clock. For example, assume that in our distributed system we have 5 machines. They are connected through a network. So we try to sync the time between all these machines. We want to say that all the machines must execute an application exactly at 12 o'clock, for example. Exactly at 12 o'clock. Is it possible? No, it's not. Why? Because syncing the time between all these machines, it is not possible. It's impossible, in fact. It's impossible. We cannot sync all the machines exactly at the same time. So the time of machine 1 is different from the time of machine 2. For example, 1 microsecond or 2 microseconds. But it is not possible to sync the time exactly the same as each other, because we are using network, and in our network many different things affects on transferring data between two nodes. For example, you are all in Iraq, okay? You sync the time of your laptop or your mobile phone with time center, okay? It is automatically synced. You automatically sync your time with time server. But the time of your machine is different from the time of your friends. Also, the hour and the minute and the second is the same. Maybe the millisecond is the same, but the microseconds is not the same, because it's not possible to exactly sync the time in network. So we cannot assume that a global clock exists in our network. Clear? Good. Some other techniques for scaling: hide communication latencies, avoid waiting for responses, do something else. Okay, you send a request to a server, your client, you send a request to a server, so you can wait until you receive the response. It's not a good idea. You can do something else while you are waiting. Make use of asynchronous communication. It is essential. Have separate handler for incoming responses. And what's the problem? Not every application fits this model. There may be some applications that they don't fit this model. Partition data and computations across multiple machines. It's another technique for scaling, for distribution. Move computations to clients. For example, consider you are filling out a web form. You want to register in a website. Sorry. You want to register in a website, and you must fill a form. For example, your name, your family, your date of birth, your national number, your passport number. You must fill it. Your email address. Okay. After you fill the form, you submit the form. All the data will be sent to the server. In the server, it will be checked if it is correct or not. For example, your email address, and you will you will give you will be noticed that your email address is not in a correct form. For example, please enter email address in the correct form. Instead of this operation, it can be checked on your computer by JavaScript codes. After you fill the form and you click on submit, before sending the form to the server, your form is being checked on your computer in terms of corrections of forms. For example, email address structure. Or, for example, you cannot input character for your age. You must input some numbers, okay? It can be checked on your computer instead of on server. So it can increase the performance, and it can be a good solution to increase the scalability. Decentralized naming services, or DNS, decentralized information systems, or WWW. For example, World Wide Web, Internet, WWW. In WWW, we can see a huge amount of information about everything: news, policy, science, everything. But this information is decentralized. It is not stored in a single server. Can you imagine that all the information in the web is stored in a single server? It's not impossible. It doesn't work. It doesn't work. So the information is decentralized in different locations, in different servers, hosts, okay? And we have decentralized naming services, or DNS. DNS is a naming services to convert the address of a website to a physical location of the server which the website is stored on it. For example, you type www.imamreza.ac.ir. It's an address of characters, but you must be connected to the server of this website. How you are connected to the website? By DNS. Look at this picture. For example, we have different locations, different servers. Every server handles and calculates about some domains. For example, .us, .jp, .net, .com, .ir, for example. So the first step is to find .ir server. So you are connecting to a server that gives you some services about .ir domain. In that server, the next part of the name is about AC, imamreza.ac.ir. So you are going to connect to the server of AC.ac, and in that server you will be find that where is the Imam Reza website. It is DNS, domain name server, or decentralized naming service. Yes, for example, you type gil.acm.org, okay? gil.acm.org. How you are connected to the server of this website? In the first step, here, you are connected to the server of org. In this server, then you find the server of ACM. Where is the ACM? So you are connected to this server, ACM, and then in that server you will be connected to the website, to the server that hosts GIL. So you can find the server that the website gil.acm.org is stored on it, and you can see the website. The website is loaded for you. Okay? Good. Another technique for scaling, we are talking about some techniques for scaling. Another technique, why it's a technique, naming DNS? Why it is a technique? Because we said that if we have a single server, that all the information of these websites is stored on this server, the bottleneck occurs. All the people must access to this single server, so the performance is decreased, so our system is not scalable. We use such system DNS to distribute our naming services, so the performance is not decreased. Okay? Another technique is about replication and caching. We talked about it. We can have some copies of data available at different machines. For example, google.com is a website about searching queries. Okay, so all the data of Google, imagine all the data of Google is stored only in one single in America. What happens? If all the data of Google is stored only on one single server in the America, what happens? All the people in the world must connect to that server. Okay, so the bottleneck occurs. So it doesn't work. It's not possible. What's the solution? Replication. Google have different servers in different locations. For example, in Dubai, for example, in England, for example, in Paris, for example, in Japan, in different locations. All the servers have a copy of the data. Okay, so people in Japan connect to the server that is nearest to them, and we connect to some servers that are nearer to me. Okay, so distribution and replication can increase the performance. It's a technique for scaling. Yes, exactly. By this technique, if the number of users in the world increased, if the number of users in the world is increased, the performance is not decreased. Google can give services, can provide service for millions of people. And you can see that this is a scalable system. Mirrored websites is another solution. It's same as replicated websites, for example. Mirrored websites. You want to download a movie and you have two links. Mirrored website 1, mirrored website 2. And you can select which website is suitable for you to download the movie. So it increases the performance. Web caches, we talked about it, and file caching. It's another technique for file caching which is done in servers and clients. Got it? And there are some false assumptions made by first-time developers. For example, suppose you are a developer you want to develop an application for distributed system, it's your first time, and you may have some false assumptions about, for example, network reliability, network security. The network is reliable. It's a false assumption. It's not true. The network is secure. The network is homogeneous. The topology does not change. Latency is zero. Of course not. Of course not. Latency in the network is not zero. Bandwidth is infinite. It's limited. We have a limited bandwidth. Transport cost is zero, and there is one administrator. These are false assumptions that may be made by first-time developer in distributed systems. Well, it's enough for today. I think it's enough. I must say that the next session at 6 o'clock is cancelled because I'm busy with something else. I must go to attend in a meeting, important meeting. So the next session today at 6 o'clock is cancelled, and we can have another section instead. We can talk about it next session, okay? So when is our next session? When is our next session? Wednesday. No, 6 p.m. Okay, today 6 p.m. is cancelled. And the next session, let me check it. Next week, yes. Our next session is next week, okay. So what is your recommendation for let me check it again. Okay, so what is your recommendation for compensatory class time? For compensatory class time. instead of this class, instead of next session at 6 o'clock? Which day is suitable for you? Are you free tomorrow? Are you free tomorrow evening? Tomorrow evening. Instead of next session that I canceled it, okay, we are going to organize another session. So are you free tomorrow evening at 6 o'clock tomorrow? Yes, tomorrow at 6. Tomorrow at 6 p.m. Tomorrow at 6 p.m. Am I free? Let me check. Yes, tomorrow at 6 p.m. I'm free. Okay, it's a good idea. All the students, do you agree with tomorrow at 6 p.m.? Let me add new poll here. Please participate. I need your votes. Please participate. One class. Only one class tomorrow at 6 p.m. Okay, we have 22 students in this class. We have 22 students in this class, but only 9 students participated in voting. Where are others? Okay, some students say no. Why? Are you busy at that time? Are you busy at that time? Next week? Okay, so next week we can have 2 sessions, okay? Next week we can have 2 sessions, 4 p.m. and 6 p.m. Is it okay for you? Good, okay. So next week, remember, next week we have 2 sessions, 4 p.m. and 6 p.m. Don't forget it, please. Okay, approved, تصویب شد, approved. Okay, next week we will have 2 sessions, 4 p.m. and 6 p.m. Have a good night and خدا حافظ.